Welcome to command line. Today we are going to see the two-sum problem from Leetcode. Given an array of integer nums and an integer target, return indices of two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. So given a list of numbers and a target number, we have to find the indices of two numbers in the list. If we add those two numbers, it should actually give the target value to us. That is a given question. And what they are telling us is every given question will have exactly one solution. We will not have any duplicate solutions, and we will not use same element twice. It means we have to add two elements at two different positions. Here are the examples. At first, nums is 2, 7, 11, 15 and target is 9. By adding 2 and 7, we can get the target 9. So index of 2 and 7 is 0 and 1. That's what we should return back. And for the second example, 3, 2, 4, the target is 6. Adding 4 and 6, we should get 6. Adding 2 and 4, we should get 6. So the output will be index of 2, which is 1, and index of 4, which is 2. And third example, 3 and 3, the target is 6. Adding 0th index and first element, we are getting that number. And the constraints, the array length can be between 2 to 10 to the power of 4. And every number inside an array can be between minus 10 to the power of 9 to plus 10 to the power of 9. So there is a possibility of having a negative number also. And target also can be in the same range. And you are telling only valid answer exists. So every question, every problem given will have a valid answer. Here is a follow-up. Can you come up with an algorithm that is less than O of n square time complexity? So the minimum expectation here is you have to implement a working solution and that can run in O of n power 2. But you can even optimize it. There is a better solution. In this video, we will see the better solution. We will see how to solve this problem in linear time. Let's take the first example itself. Nums is 2, 7, 11, 15. And target is 9. So by adding 2 and 7, we will get 9. But to get that, I'm going to traverse every element into the list. So now I have 2 as my x. And what should be the complement to reach 9? So I expect y should be 9 minus 2. So if I say x plus y equal to target, I can say y equal to target minus x. So when I have 2, when I'm traversing 2, I try to find what should be the other element in the array which will satisfy the condition. So that complement is 9 minus 2, which is 7. And if I can search in the list whether 7 is present, if I can able to get the index of the 7 from the list, I can immediately return the index of 7 and index of 2 as the output, right? But the problem here is the given list is not searchable. It is just a list. To identify, to search a particular element into that list, we have to only traverse. To avoid it, let's put all the elements into a searchable data structure. Let's have a hash map. In that case, we will be traversing twice the list, once to build the hash map, another time to identify the indexes. So instead of that, we can do that in a single pass itself. We don't need to worry about the untraversed elements. We will just push the traversed element into the hash map, and when you reach the second element into the index, you will get the first element from the hash map. You will understand that when we actually do the dry run. Let's take the same example. 2, 7, 11 and 15 and target is 9. Let's have a hash map. And this hash map, we are going to store the value as a key and index as the value of the hash map, because we have to return the index, not actually the value. So what we are going to do is we are going to traverse the list from left to right. We will take 2 first and we will calculate what is the complement to reach the target if one element is 2. So the complement will be 9 minus 2, which is 7. And we are not going to search 7 in this list. Instead, we are going to search in the hash map. I am checking whether 7 is here. But here this hash map is currently empty, so 7 is not here. So I'm coming back. But before going to the next element, what I'm going to do is I'm going to insert 2 into the hash map. Currently I'm traversing in 2, right? So I know the index and the value of 2. So I'm going to insert that into the hash map. So the value is 2 and the index is 0. When I am traversing the next element 7, I am going to compare the complement. So complement equal to 9 minus 7, that is 2. Now we have to search 2 in this hash map. Yes, we already have 2 in the hash map and the index is 0. We get this value from the hash map, and we are currently traversing 7, and 7th index also, I mean the index of 7 also we know that. So we'll return index of 7, which is nothing but 1, and then we can return index of 2, which is from the hash map, we can return as 0. So we can return the answer like this. Let's implement this one. So first we are going to create an empty dictionary for our hash map. Then we are going to traverse every element in the list, and we need to return the index, so we need to keep hold of the index also. So using enumerate, we can get the index and value both in Python. Now we are going to compare the complement target minus val, and we will check whether complement is there in the hash map. If it is there, we can simply return the index of the val and the index of the complement. If it is not there, then we are going to insert the current value into the hash map. And we don't need to worry about the corner cases and edge cases because they have already mentioned one valid answer exists in every problem. Let's run this code on the example cases. We got all 3 cases successful. Let's submit the solution. Yes, we got an accepted solution, and 63 test cases out of the 63 test cases succeeded, and we are at the top. Hope you enjoyed the video. If so, please give a thumbs up and subscribe to the channel for more such videos. Thank you for watching.